In this video, we are going to be looking at graphing linear equations. So a linear equation basically just means that it's a straight line. That's what linear means, that it's an equation of a straight line. And you find kind of two common ways that these are written. One's called standard form, where it looks like ax plus by equals c, where a, b, and c are numbers, or real numbers. Or you see it in slope-intercept form, which is y equals mx plus b, where m and b are real numbers. So we're going to look at two different ways we can graph these equations, one using a table of values and one using x, y intercepts. So let's start with using a table of values. So when we are completing a table of values, what that means is we are looking for points on that line. And if we can graph those points, then we can connect them with a line and therefore graph our line. And so when you're creating a table of values, you want to create a table that has x and y. And you're going to choose some x values to substitute into our equation. And I like to choose the numbers 2, 1, 0, -1, -2. You can choose any x values you want, but the reason I choose these ones specifically is because 2, 1, and 0 are nice, easy numbers to work with, to multiply with. And also they're in the center of our graph. And so it just kind of makes the most sense for me to see, okay, what does my graph look like right in the center using some nice, easy, friendly numbers. So that's why I use these ones. And I'm hoping that within those 5 numbers, I can find at least 2 y's that are nice whole numbers for me to graph. So what I'm going to do is I'm going to take each of these x's and I'm going to substitute them into my equation, y equals 3 over 2x minus 3. So I have y equals 3 over 2, and then for x, I'm going to put in my value of 2, and then I'm just going to solve. So 3 over 2 times 2 is just 3, minus 3, which equals 0. So one of my points on my graph is the point 2, 0. So let's graph that now. Right there, 2, 0. So over 2 and up 0. And I'm going to continue to do this with my other points. So I'm substituting in the point 1. So I get -3 over 2. That's not a really nice number to try and graph, so I'm not going to graph that one. I'm looking for some whole numbers. We don't want to do an approximation here when we're graphing and kind of guess where -3 over 2 would be. So let's keep going and see if we can find another. So 0 minus 3. Okay, so there's another nice one. So 0, -3. And really, we only need 2 points because we know it's a straight line. And so once you connect those 2 points, then you're good. But I like to try and get a third just to kind of verify my work and that I haven't made a mistake. So I'm going to keep going. That one's not a nice one to graph, so let's try and find our last one here. And there's another nice, neat point, -2, -6. And so I'm going to take a ruler or a nice straight edge, and I'm going to draw a line connecting all 3 of these points as accurately as I can. And then there's a few things that we want to make sure we're doing when we're graphing. The first is that we want our line to go all the way through the graph. we don't want to just connect our 3 dots because that's called a line segment. Our graph actually keeps going past the points we've included in our table of values. So I want to continue to draw that line all the way through my graph. You'll also notice that my line has little arrows on each end, and that's because, again, that line just keeps going past my graph even where I have pictured. And so we want to show that this line just keeps on going and going and going. So it goes all the way through the graph, and we put little arrows. And then the last thing I like to do, especially if I'm graphing more than one line on the same graph, is I like to label it. And so somewhere along the line, I'll include a little label to show which line that represents. Okay, so again, 3 things we want to look for when we're graphing: that we're using a nice straight line all the way through the graph, we're including some arrows, and we're labeling our line. Okay, let's try this next one. Again, we're creating a table of values. So I'm going to create my X and Y table. I'm choosing some X's. Again, I like to choose these ones, but you can choose whichever ones you like. And then we're just going to substitute these numbers into the equation, and it looks like this equation's in standard form. 2x plus 3y equals 4. But the process is the same. Because I'm solving for y, I like to rearrange this equation first so that I don't have to rearrange it each time I substitute a number in. So I'm going to take our equation, and I'm going to rearrange it so that it's y equals. So first I'm going to get rid of 2x. To get rid of that 2x, I'm going to subtract 2x from each side. So I get 3y equals 4 minus 2x. So by getting rid of it on one side, you end up kind of moving it over to the other side. And now I'm going to divide by 3 again to get my y by itself. So I get 4 over 3 minus 2 over 3x. And now I can substitute my numbers in without having to rearrange that equation every time. So let's try our first one. I'm going to substitute 2 in for x. And I get 4 over 3 minus 4 over 3, which is 0. So when x is 2, y is 0. Let's try it again with our x being 1. So that's not a very nice point to graph, so we're not going to graph that one. We're going to keep going to see if we can find another point that's nice to graph. So I'm going to substitute in 0. That one's not very nice either, so let's keep going with our negative 1. And I end up with y equals 6 over 3, or y equals 2. Okay, so I got 2 nice points, but let's do our last one there just to be sure. And I don't have another nice point. So I only have 2 nice points that I'm going to use to graph. I have x is 2, y is 0, and x is negative 1, y is 2. So I get 2, 0, and negative 1, 2. Again, all we really need is 2 points to graph. I tend to like to try and find a third just to verify my answer. But I really just need 2. Again, I'm drawing a nice straight line through my points, making sure it goes all the way through my graph. I have arrows on each side, and then I'm going to label it using my original equation so I know which line that represents. Another way that we can graph is by finding the X, Y intercepts. Essentially, what we're doing is creating a table of values with only 2 points. We're checking where it intercepts the x-axis and where it intercepts the y-axis. So what does that mean? Well, at some point, because it's a straight line, at some point we know that that line is going to cross my x-axis at some point, and I want to know where that is. So if we look at some points along our x-axis, this point would be 1, 0. This point would be 3, 0, 5, 0, and so on. And so they all have in common, if I look at those points, they all have something in common with each other. And that's the fact that when it crosses, when a point is on that x line, we know that the y coordinate is going to be 0. In order for it to cross that line, the y coordinate has to be 0. So in order to find out where our line crosses the x-axis, I'm going to find out, well, what is x when y is 0? So if we're looking for the x-intercept, we know that our y has to be 0. So I'm going to take my equation and I'm going to substitute 0 in for my y, and I'm going to solve and see what x is when y is 0. So I get 12x plus 0 equals 24, or 12x equals 24. And now I'm going to divide both sides by 12, and I get x equals 2. So we know that when y is 0, x is 2, and so my line crosses at 2, 0. The opposite is true for our y-axis. At some point along that y line, I know my line's going to cross, and all of the points along our y-axis are going to have my x be 0. So to find the y-intercept, we're going to set x to 0. So again, it's like I'm finding a table of values, except I'm only looking for 2 specific points. What is x when y is 0? And what is y when x is 0? And so I'm going to substitute 0 in for x. Get 0 plus 6y equals 24. So 6y equals 24. And I'm going to divide both sides by 6. And I get y equals 4. So when x is 0, y is 4. So now I have my 2 points. I've graphed them, and now I can use a ruler to connect them with a nice straight line. That goes all the way through my graph with arrows on each side, and then I'm going to label it so that I know what that line represents. Let's try another one. Again, in order to find my x-intercept, I'm going to make my y equal to 0. So I'm substituting 0 in for y. And I get x is 4. So x is 4 when y is 0. And for my y-intercept, I want my x to be 0. I'm going to divide both sides by 2, and I get y equals 2. And I'm going to connect them with a nice straight line. And then we're going to label it. In order to identify what the line is. Now, the positives to this method is that it's a lot quicker. We're only finding 2 particular points versus up here when we are finding a bunch of different points and trying to find 2 points on that line, it maybe is a little bit more tedious and takes a bit more time. However, you can always use a table of values to graph a line. It might take a little bit more time, but you can always use it. It's a method that works for every equation. But XY intercepts, we only get 2 chances to find a nice graphable point. So if your X or Y intercept doesn't work out to be a nice point to graph, then you can't really graph it when you're using pen and paper. Because again, you're going to have to kind of guess where that fraction lies on that graph, and it's just not very accurate. So the positive is it's quicker than a table of values, but our downside is that we kind of need them both to be nice whole number points in order to graph effectively with pen and paper. Okay, so I would like you to rate yourself on how you're doing with graphing linear equations. You're going to give yourselves a thumbs down if you're having some trouble with this and you need some help. You're going to give yourself a finger pointed if you need some more practice graphing linear equations, and a thumbs up if you're like, I can graph linear equations. I don't really need any more help or practice with this.